of course, that for multiplication, you can represent it using a dot, using parentheses, using nothing, and using that old-timey X you probably saw in grade school. I'll use the dot here. So, multiplication and division are basically so nice. In math, remember that multiplication is your friend. In general, is your friend. In general, multiplication is going to be the one operation that plays the way you want it to. Always remember that. Remember that for the other stuff, you're probably going to have to do more work than what you want. But for multiply, it really is as easy as you'd like. For example, here, with multiplying, you don't have to worry about anything. You just do that. You just multiply. You go across the bottom and across the top. And that's all you do. So, here I have negative 5 times 3. That gives me a negative 15. On the bottom, 6 times 10, that gives me a 60. Now, of course, I should reduce, just like always. But as far as the process goes, that was it. I am going to reduce it, though. Let's see. When I reduce this, I'll divide the top by 3. So 15 divided by 3 gives me 5. I'm going to keep that negative on there. 60 divided by 3. Let's see. 3 goes into 6 2 times, and I've got a 0. Oh, I guess I can keep going, can't I? If I take a 5 into that, that's going to give me negative 1. 20 divided by 5, that's going to give me 4. So actually, I got negative 1/4. And there are techniques that can help you do this in one step that you may have learned in 060. Again, I am indifferent. As long as you're able to work these problems, that's okay. And if you're not, you need to request stuff from me as far as supplemental lectures or go to tutoring. Something here you may also want to note. Here I've written negative 5 over 6 as the fraction. It's the same thing as negative 5/6 or 5 over negative 6. Remember, when you have numbers with opposite signs, you know, so like a positive 6 and a negative 5, or a positive 5 and a negative 6, it's just a negative number. So we only see that negative one time. You can write this however you want when you're writing down your fractions, but do not write that negative more than once. If you do, it cancels. It'll mess up your whole problem. I default to always sticking my negatives on top. Always. That's what you will always see me do through this course. But sure, it is the same as that if you happen to prefer something else, or if you see a problem that starts off differently. Another example. How about this? We'll do a division example. I'm not too creative here. We'll say negative 5/6. This time it's divide by 5/9. The idea being, multiplication is your friend. We have divide here. We don't want it. What we're going to work with is we're going to work with multiplication. So to do that, you will always do this when you have fractions. You will always change your divide to a multiply. To do that, you get what's called the reciprocal of 5/9. You flip that fraction. So I get 9 over 5. I'm going to carry down my first one. I didn't change it at all. And I get something like that. So to change this to multiply, I had to flip this fraction and get 9 over 5. Then you do what you'd like to do. You multiply straight across on top and bottom. So negative 5 times 9, that sounds like a 45. Negative, since I have opposite signs. And on the bottom, 6 times 5, that's a 30. Once again, you can divide stuff out. I see 5 easily, so I'm going to do this in my mind with you. If you're faster than me, that's a-okay too. Negative 45 divided by 5, let's see, that's going to give me a negative 9. And 30 divided by 5 is going to give me a 6. Very interesting. This actually goes down more, doesn't it? So right here I divided out 5. And right here, I'm going to divide out 3. And you may be able to see a shortcut with me. Negative 9 divided by 3, that's a 3, still negative, over a 2. Okay. Or you could write, let's see, 2 goes into 3 one time, and we have a 1 left over. Notice again, the negative's only happening one time, even in a mixed number. Notice something for me, though. Sure, I kind of did it the long way on accident, to be honest. But when we reduced here, look at those numbers that we pulled out. You had a negative 5/6 times a 9/5. When you have multiplication, remember, with the fractions, what keeps them equivalent is changing them by times or divide on top and bottom. What that means to you is when you have multiplication, multiplication only, not division, this is the only time you can cancel like this. When you have multiply attaching your fractions, you can cancel stuff that you have on top and bottom. So you actually could have seen the same problem this way. You could have said, oh, I have multiply with fractions. That's on top and on bottom. So I'm going to divide out of 5. That gives me a 1 and a 1. Down here, let's see, between these two, can I cancel anything? Sure. Pull out a 3. I get a 2. Pull out another 3. I'm going to get a 3. So basically I reduced, just like up here, by pulling out my 5s and my 3s. So see, I pulled out my 5s and I pulled out my 3s. But you have to do it something on top, something on bottom. It doesn't matter if it's crossways. It only matters that I took a 5 out of the top somewhere and out of the bottom somewhere. And then if you've reduced this way, well, 1 times 3, that still gives me a 3 that's negative over a 2. Whatever floats your boat on that. It all works. Let's see. Let's play with some decimals. Multiplying and dividing. Woohoo. Okay, we have negative 6/8. Just for fun factor, I will write that with a parenthesis, times negative 2.1. When you multiply decimals, you don't have to worry about lining them up. You just write them. However it feels natural to you, write them, work it out. Then if there's negatives involved, think about that part at the very end. So I just wrote one on top of the other, and then I take each piece of the bottom one and I share it everywhere on top. So 1 times 8 gives me 8. 1 times 6 gives me 6. Now since I'm scooting over on the bottom for the next one, I also have to shift over 1 on the next line. So you can put a 0 there if you want, a line, or you can just scoot over. The idea is you stepped over here, so step over on that next line. 2 times 8 gives me a 16. Carry the 1. 2 times 6 is 12, 13. And that was it. So I'm going to add the two things that I just multiplied, the two rows that I created. 8 and nothing gives me 8. 6 and 6 gives me 12. Carry the 1. 3 plus 1 is a 4 and a 1. Now you might say, hey, we didn't line these decimals up. We just multiplied everything on top by everything on the bottom. So when did those come into play? Well, now, at the end. What you do is you look and you say, how many digits, how many numbers do I have on the right-hand side of the decimal? I have 1, 2. So I'm going to say 1, 2 for my decimal. And the answer then is going to be 14.28. Or more properly spoken, 14 and 28/100ths. Next example. Let's look at a division problem. Actually, we'll look at 2 of these because these are the more tricky ones, in my opinion. First, we're going to look at this. 9 and 44/100ths divided by negative 8. Oh yeah, since those were both negative, up here, this right here was a positive. So actually I forgot that last step, but when you go back over here and write the number, you check out these two signs. If they're the same, remember you get positive. And so that's why we just stopped with the 14 and 28/100ths. Had one been negative and one positive, yes, you would have a negative. Okay, so now we have this. Next example. 9.44 divided by negative 8. I'm not going to write those negatives, they will bug me. I'm just going to be sure to include that at the end. So the idea is, this over here is nice. It's nice and friendly. But you always want the decimal to be on the far right hand side, which it is, so we're okay. Then what you do is if you have any decimals underneath this bar, you bring it to the top, straight above. Then you divide like you'd like to. 8 goes into 9 one time. 1 times 8, that's 8. Subtract to get a 1. Bring down your 4. 8 goes into 14. let's see, not quite 2 times. I guess it's just 1 time again. Because 8 times 2 is 16, that's too big. So we got a 1. 1 times 8, that's an 8. And 14 minus 8 gives us 6. Bring down our 4. And 8 goes into 64 8 times. 8 times 8, that's 64. We can stop with a 0. So now that you have this, you have the quantity 1 and 1800ths. Remember that these had opposite signs, so your answer is going to be negative. One more division example, because again, those can get a little bit more tricky. Remember, by the way, when you write this stuff into long division, that really, the way we do it in the U.S. is kind of backwards. We write left. It's the only time that we ever start thinking backwards to the left, and I'm not sure why we do. If you're from another country, you may write it differently, and that's fine by me. But the way that most of us have been raised is to go backwards with this. To start with the first number, 1.32, and to write to the left. So you work left. You write this thing to the left for long division. Okay, so now we have a decimal on both sides, an explicit decimal. And notice something for me. We have a decimal in front of 27, or in front of our 2700ths. The idea is it has to be adjusted pretty. On the outside, with that divisor, you do not want decimals to have to deal with. So what we do is we say, you know what, I really want that to move 2 places to the right. Just like with a fraction, because remember this is essentially a fraction, isn't it? It's a divide problem, just like a fraction is. When you do something to one part, to the top or bottom, you must also do it to the other, the top or bottom. So here, let's see, that was the bottom, we moved it twice, so underneath, you also move the decimal twice. So you have to adjust your decimals. If I could spell it would help. Divisor, adjust your divisor, decimal. That's something you want to be sure to remember. So now I have 27 into 132 with the decimal. So I moved both decimals. With this, once again, I just take the decimal to the top. 27 doesn't go into 13. It does go into 132 4 times though. To do that in your head, I am cheating with a calculator to save time, but to do that in your head, basically I would round. I would probably say 30 into about 130, something like that. Other techniques are also okay as always, but generally I round and then I'll test by hand if you don't have a calculator. We get a 4 there. 27 times 4 gives me 108. Or 108, it's better, okay? I get that. When I subtract, I have 24. I can always add zeros after that decimal, so that's what I'm doing. Once you have the decimal in place, you may always add 0. So now I have 27 into 240. It's going to go 8 times. And 8 times 27 gives me 216. It gives me a 24. Add that 0, and hopefully you're starting to see that you're going to go in a circle. Because see how you're getting the 240 over and over, and the 216? Since we are repeating here, we just go to the top and we say, you know what, we see a pattern. That 8's going to go on forever. I'm going to stick the line over one of them. Usually I just put it over the 10th place or the first place where it started repeating. So the answer to this problem is 4.8, where the 8 repeats. Again, you look at the signs, they were both positive, so your answer is also positive.